So remember that the mole is like a dozen. It's a way for us to count atoms and molecules and compounds. Why? Because they're so small and they don't have much mass. So it's so difficult for us to count them. So there was this guy called Avogadro, and he assigned a number of 6,02 times 10 to the power 23 as a mole. Like 12 is a dozen, this number is a mole. So when we use the mole, I want to remind you of something that you might have seen before called the mole triangle. And the mole triangle is a way for us to move between various measurement units that we can physically understand. For example, mass, for example, number of particles, and also volume. Now, the mole is the central part here. So let's say, for example, you have mass and you want to take it to moles. The formula that you will use is going to be N equals mass over molar mass. So if you have mass and you want to calculate moles, what you're going to do is you're going to take the mass and divide by the molar mass. Molar mass, of course, being the molar mass that we get from the periodic table. The molar mass for oxygen, for example, O, is 16 grams per mole. The molar mass for O2 is going to be 32 grams per mole. So remember that mole and molecule is not the same thing. A molecule of O2 has 2 oxygen atoms in it. That's why it's called a diatomic molecule. Diatom, 2 atoms. A mole has literally trillions of molecules in it. So we're going to move from mass to moles like this. If I want to go from moles to mass, I'm going to have to multiply with my molar mass. So I can say mass is going to equal moles times my molar mass. The same applies if we want to move from moles to number of particles and vice versa. If you move from moles to number of particles, you are going to multiply with Avogadro's number. If you move from number of particles back to moles, you are going to divide by Avogadro's number. And this is the formula that we use. N for moles equals the number of particles, and it can be atoms, it can be molecules, it can be compounds, it can be ions, divided by Avogadro's number. Avogadro's number again is 6,02 times 10 to the power 23. Now if we want to move from moles to volume, and this is only at STP where this applies, remember. If we want to move from moles to volume, we are going to multiply with molar gas volume. If we move from volume back to moles, we are going to divide by molar gas volume. Molar gas volume, by the way, is a constant. You'll find it on your formula or information sheet, 22,4 cubic decimeters. This value means that at standard temperature and pressure, any gas has a volume of 22,4 liters or 22,4 cubic decimeters if you have 1 mole of that gas. So very important. But we know, of course, that we don't normally have standard temperature and pressure. So I just want to add on one more thing, and it's not part of your mole triangle, but it is something that you can use, and that is concentration. Concentration equals moles per cubic decimeter, and the formula C equals N over V. So you can use this as well as part of your mole triangle to move between concentration, volume, and moles. So when you have the mole triangle memorized, make a note of it somewhere on your answer sheet when you start writing your paper about chemistry, so that it's somewhere where you can see it and use it. This is very helpful because what happens when we have moles is we can use that to calculate mole ratios. Mole ratios is like the recipe we use. Okay, so I actually have an example from a previous question paper that I want to share with you. This question paper, let's go through all of these questions together. Firstly, it tells us we have NaCl plus H2SO4 forming Na2SO4 plus HCl. So when I start off with this, I see that this, of course, is going to be an ionic compound, NaCl, and I see here that I basically have ion exchange happening. If we have to go and balance the chemical reaction, if we have a look at it, I see that on the left-hand side I have 1 sodium, on the right-hand side 2 sodiums. On the left-hand side I have 2 hydrogens, on the right-hand side I have 1 hydrogen. So the easiest would be to add a 2 here in front of NaCl. This will give me 2 sodiums on each side, 2 chlorines on each side. If I add a 2 in front of HCl now on the right-hand side, and it's balanced. If you want to go and have a look at some other videos about balancing that are available, I'm not going to discuss it again now, but make sure that your chemical equation is balanced before you continue. Then here it says, grade 10 work, use the law of conservation of mass to prove that the chemical reaction is now balanced. So what you can go and do then is take this formula and use your periodic table to substitute values to prove that it is actually balanced. So here it will be 2 times, and now NaCl is 23, plus chlorine is 35.5, plus I have 2 hydrogens, 2 times 1, plus sulfate is 32, plus 4 times 16, and that's supposed to be equal to 2 times 23, plus 32 for sulfur, plus 4 times 16 for oxygen, plus 2 times 1 for hydrogen, plus 35.5 for chlorine. If you go and calculate this, you will see that this is actually a balanced chemical reaction. We show here that the mass of my reactants is equal to the mass of my products. This was grade 10 work. We are not saying we have the mass of the reactants or we have the mass of the products. We're saying if we have a balanced reaction and we follow our recipe and the amount of moles needed, that this makes sense. Now, this is where many learners struggle, because now when we tell you that you have a different mass or a different something else, then they don't know what to do. Remember, the number in front of your chemical compound is just the recipe. It gives you the ratio in which substances will react. If we go and look at our next question, determine the molar mass of Na2SO4. Molar mass, if we use our periodic table, sodium is going to be 2 times 23, plus sulfur is 32, plus 4 times 16. And if you go and use your calculator to do this, 2 times 23 is 46, plus 32, plus 4 times 16 is 64. It gives you 142 grams per mole. Sometimes you'll see that they actually give you M subscript R. That R means relative molar mass. In that case, you don't have to give the unit. But that's the only exception. Normally, we always give the unit. So just be cautious. Okay, then the next question. Na2SO4 or sodium sulfate is the salt that forms when we have table salt and sulfuric acid. Calculate the percentage of sodium in sodium sulfate. So if we want to go and calculate the percentage of sodium, we first have to go and calculate how much sodium do we have in sodium sulfate. We know the molar mass of sodium is 23, but as you can see, we have 2 sodiums in sodium sulfate, which means that we're going to multiply this number by 2 to give us 46 grams per mole of Na2SO4. So to go and calculate the percentage, we're going to take the 46, divide it by 142, and then multiply it with 100. 46 divided by 142 times 100 is going to give you 32.39% sodium. So these are all basics from grade 10, nothing new here so far in grade 12, but knowing these basics makes our lives just so much easier. Determine the empirical formula of a compound that consists of 40% carbon, 53.33% oxygen, and 6.67% hydrogen. If we go and do this calculation, our first step, as you can see here, it's for 8 marks. So our first step will be to say, assume, and it's the only safe time to assume in science, assume that you have 100 grams of this sample. It would mean that you would have 40% carbon, 53.33% oxygen, and 6.67% hydrogen. So now that we go and rewrite that, this will give us grams, not percentage. 53.33 grams, oxygen 6.67 grams, hydrogen. Then what we do with that is we go and calculate how many moles we have. We have mass, so we have to move to moles. So what we need to go and do is we need to go and use our mole triangle. When we move from mass to moles, we have to divide by the molar mass. So your next step will be to go and find the molar mass. The molar mass for carbon from your periodic table is 12 grams per mole. The molar mass for oxygen, and now remember I'm just using O, I'm not using O2 because I'm trying to calculate the empirical formula. It's going to be 16 grams per mole, and then the molar mass for hydrogen is 1 gram per mole. So what I do now is I take the mass that I have and I divide it by the molar mass. This is the formula. N equals mass over molar mass, which is going to be 40 divided by 12. Over here, N equals mass over molar mass, same story, 53.33 divided by 16. And for the last one, N equals mass over molar mass. I hope you're getting sick of writing down the formula because it means that we get marks for that. That's why we do it every time. 6.67 divided by 1. Okay, so what's 40 divided by 12? It's going to give us 3.33 moles of carbon. We go and we do 53.33 divided by 16. It gives us also 3.33 moles of oxygen. And then lastly, this one I'm not going to use a calculator, 6.67 moles of hydrogen. So when we have this, we are going to now go and divide it by the smallest number we have here. Okay, the smallest number is 3.33. So I divide by 3.33 everywhere. And now I can get an idea of my ratio in which this will bond. So we see it's going to give me 1 carbon for every 1 oxygen for every 2 hydrogens. Now normally when we write down the name of a compound, we write down the symbols from the periodic table in alphabetic order. Therefore, the empirical formula here will be CH2O. So these are all basics. Now, I am going to give an example of what we're going to do with this balanced chemical formula. Okay, so we're going to take this chemical formula over here, and I tell you that you have 30 grams of NaCl, and I want you to calculate how many grams of HCl will form. Happy with that? 30 grams of NaCl, how many grams of HCl will form?